Hello, everyone. Thank you all for joining this evening. We are going to have a GMAT free prep hour, and I am so happy to see everybody here. Excellent. Why don't you, as you join and chat here, why don't you just say hello and tell us where you're located? I am tuning in from Ann Arbor, Michigan right now. It's been a rainy summer here. How about all of you? Excellent. I hope that everyone is excited for some GMAT talk tonight. That's why we're all here, right? I'd love to know too where you're at in your stages of GMAT prep. So as I continue on here, I'd love to hear that from you. Have you just started studying? Have you been studying for a while and you're maybe thinking of taking the exam, or you're trying to continue to make some additional progress here? There are just all sorts of people joining the GMAT free prep hours, right? So give me just a moment here. Does not matter where you are at in terms of joining. You can definitely join no matter where you are in your prep. Okay. All right, so we are taking a look here at Quant this evening. Quant is, wow, I was going to say it's my favorite section, but both Quant and verbal sections are my favorite. I couldn't possibly choose one or the other, honestly. I see some folks have been studying for just a while now, resuming after a long break. Excellent. I think this is going to be a really good class session for both of you, honestly. Have completed 3 out of 9 classes with Manhattan Prep. Great, that's awesome to hear. What I'm talking about tonight and why I enjoy giving these free prep hours is a topic that we touch on in class, but we don't dig deep into. And that's what's really nice about GMAT free prep hours. We have a little bit of a chance to dive into topics that we don't always have time to cover in class. And this evening, as I mentioned, it's going to be a quant topic. If you like our free options, then we do have other free materials available to help you study. You can try a live GMAT class, the first class session of our course. It's very helpful. You go through data sufficiency, how to approach data sufficiency, how to make sure that you can be successful. And we also talk about sentence correction. So it truly is a content-focused course. All right. Tonight, as I mentioned, we're covering Quant. We are talking about hidden constraints. So if any of you have been looking at Quant recently, some problems incorporate this, some don't always, but it's a really helpful topic to keep in mind because you're just never going to know when it's going to come up, right? And a lot of Quant topics are like that. You want to make sure that you have them in your back pocket and that you have these topics that you're sort of tracking and that you're making sure that you think about regularly, because that's the only way that you're going to notice them when they do come up, right? And this one in particular is just extremely helpful, can be a big time saver in particular. And I would be remiss if I didn't mention, I have been counseling my students a lot differently lately. I used to talk to them about how to be successful in problems. And more so over time, what I have been saying is that you have one main goal on the GMAT, and that is to use your time wisely. You're not trying to get problems correct. I know that sounds crazy. You're not trying to get problems correct because you can't impact that on the official exam. You can't know whether you got a problem right or not. You can do your best, you can follow a good process, and you can make good decisions about how you're using your time. That should be your primary goal, right? Don't ever use too much time for any one single problem, because that problem isn't going to be your path to your goal score, right? It's the whole thing that you have to think about, the entire exam, both sections. So you really want to be using your time wisely and making sure that you get to the end of a section with plenty of time left. hidden constraints ties in with this really nicely, because when you notice this come up, tends to save a lot of time. And that's the name of the game. If you get a problem correct in your practice, but you spent too much time on it, that still is really a miss for you. You want to review that problem and make sure that you can find a quicker way to solve and be successful. I saw a question in chat here about testing in a couple of weeks. Any tips for last minute prep? I think this is a good one, honestly. If you are coming up on your testing period, you don't want to be doing a lot of intensive studying for the couple of weeks leading up to your exam. Ultimately, this is not a test that you can cram for. It is one, though, that by getting more and more strategic, you can be more successful with the content knowledge that you already have, right? So as you think about coming up on your exam date, learning some patterns and some ways that you can save time on particular problems is very helpful. And then I would say longer time sets as well, because you want to make sure that you are assessing, am I using my time wisely? And then really tracking that through time sets. You want it to be a habit once you get to the official exam. You want to know exactly what 2 minutes per quant problem feels like, and make sure that that's something that you are sticking to, and that when tough problems come up, you're bailing instead of over-investing. All right. Hidden constraints. We are actually going to jump into a problem, and I'm going to demonstrate using this problem what hidden constraints are. I think the name gives you some clues, right? Ultimately, though, I'm going to give you 2 minutes on this next problem. I think that you all can tackle this one. What I would recommend is set a goal for yourself on every problem that you attempt. And for this one, I want to give you a goal. Make sure that you're using your 2 minutes wisely by taking time up front to really understand the problem. Don't jump right in and start solving. Don't try to use the first solution method that comes to mind. Really take a moment and think about it. All right. You are going to have 2 minutes to solve. And your time starts now. Okay, that is the end of your 2 minutes. All right. Please send me your answers via chat here when you are done. I'd love to see what the consensus is. How did everyone feel about that one? Did it feel like it was something manageable? Did it feel like it took you a lot to accomplish? And we're going to talk a little bit, obviously, about hidden constraints, but also just about approaching this problem in general, right? Hidden constraints is something that fits within the bigger framework of what you're looking at. You want to make sure that your approach to every problem is solid. All right, let's take a look at how to solve this one. And when I asked you all to focus on understanding first rather than jumping right in, I was also setting that goal for myself when talking this through. So I want to make sure that we definitely spend a little bit of time here just understanding the information that we're given, right? That's an important step to take. All right. Looking at the information we have then, a bookshelf holds paperback and hardcover books. So I know I'm working with two different groups. The ratio of paperback books to hardcover is 22:3. Okay. So at this point, I probably would be writing something on my paper. I want to make sure that I keep this information organized, right? So I've got paperback and hardcover, and my ratio is 22:3. How many paperback books are on the shelf? Now, the first thing that I'm seeing here is that we're giving information about a relationship, right? A ratio is a type of relationship. But we're asked about a specific number, which is really interesting. So even before I jump into analyzing the statements themselves, what I'm immediately thinking is that I'm going to have to find a way to tie myself to the world of real numbers here, right? Okay. The other thing that I'm noticing here is that this is a part-to-part relationship. That's what a ratio is. It's showing paperback to hardcover. I know, though, that I can actually change that formatting and use this in other ways. We tend to think of fractions, decimals, percents, and ratios all as being interchangeable, right? So fractions, decimals, percents, ratios. If I have a fraction of 1/2, I can write that as a decimal, 0.5. I can write it as a percent, 50%, or I can write it as a ratio of 1:1. They're all just different types of relationships that you're going to see. Now, that matters in particular for this problem, because as we look at the next statements here, I'm going to end up using one of those other formats. All right, looking at these two statements, I like statement 1 a little bit better simply because it's shorter. Statement 2 looks like it's probably more complex. It'll take me longer to read, certainly. So I'm going to start intentionally with statement 1. You should be intentionally starting with a particular one. The number of books on the shelf, so the total number I'm reading, is between 202 and 247 inclusive. So I know that the total number of books is somewhere in this range. Now, if you noticed something about this particular pattern that was interesting, let me know in chat as we're talking about it here. I'm interested to see if anyone caught this. Okay, the first thing that I'm seeing about this is that it doesn't tell me the number of paperback, right? So that's what I really want to know, is that final number of paperback books. However, I also said, I predicted early on that I needed to tie myself to the world of real numbers. So as I'm thinking about hidden constraints in particular, which is the topic of this class, I'm wondering if there might be a constraint that forces the number of paperback books to be only one particular choice in this range, right? Because I know I have this relationship between paperback and hardcover. So given that I have this relationship, I'm like, I think I can come up with the number of paperback books if I can figure out the number of total books that must be within this range. There are quite a few different options here though, right? And I don't want to test all of them. That sounds like a lot of work. If something sounds like a lot of work on the GMAT, you do not want to go down that path. So instead of looking at it just as a total number of books, I want to look at it in terms of the relationship that I already have here. And I want to see what arises essentially. All right. I realize here that if I am thinking about paperback and hardcover, I could convert these to fractions. But when converting them to fractions, I need to have part over whole. The whole here would be 25. And if you have not covered the unknown multiplier in ratios, you definitely should go and look into that because it's very helpful. But essentially, I can think about all of these as having just a little x after them, right? There's some number that these could be multiplied by. Maybe it's 1, maybe it's 2. So if I had 22 to 3 paperback to hardcover, for example, it doesn't mean I have that number of books. I could have 44 and 6, for example. But in that case, my total would be 50, right? So you can see that this pattern will continue. You can continue to write a couple of examples for yourself to ensure that it does. But ultimately, what I'm looking at here is that my total number of books must be a multiple of 25. That is an example of a hidden constraint. This is not something that's immediately obvious, but it makes this problem a lot easier to assess. Kent, I saw your answer here. Yeah, there's only one combination that works out ultimately. So if I think about multiples of 25, 100 comes to mind really quickly, right? But that's not in this range at all. So I'm going to multiply this again and see if I can come up with something closer. 200 is getting a lot closer, but it still doesn't fall within the permissible range. The next one is going to be 225. That's going to work out. Then 250, that is also outside my range. The only multiple of 25 that falls within this range is 225. Now, I just saw Varun, your comment in the chat here about the number of paperback books. I think that's great. You used the information you had about the relationship to go back and assess that. Ultimately, I don't even need to do that though. I know that I have this relationship between paperback and hardcover. I know that I could get the total number of paperback books by themselves. So I'm going to stop right here and call this sufficient. If I don't have to do any more work, then I am not going to do any more work. And that's a very common concept, honestly, when it comes to data sufficiency. You want to train yourself to do only the amount of work that's absolutely required for you to do. You do not want to try to do more work than that. All right, statement 2 then. We're going to make our little grid here. So if you are not using an answer choice grid to track your eliminations, I would strongly recommend that you do this. I started with statement number 1 here, which means that I can cross out B, C, and E as possible answer choices because I found that statement 1 was sufficient. So my only answer choices left that are viable are going to be A and D. All right, looking at this point, I have a 50% chance, by the way, of guessing, right? So even if I didn't know what to do with statement 2, I'm in decent shape. All right, looking at this one though, if 18 paperback books were removed from the shelf and replaced with 18 hardcover books, the resulting ratio would be 4:1 of paperback to hardcover. I feel really good about this one immediately. I have a relationship initially in the problem itself. I predicted that what I needed was to be grounded in the world of real numbers. And statement number 2 is grounding me in the world of real numbers right here. But I will show you how to go about doing this one. All right, so looking at this, I want to picture this as a ratio, but I kind of want to put it in fraction form because I think it's going to be easier to look at. And the unknown multiplier is going to come into play here as well. I know that I have 22x paperback books. The real number is 22 times something, right? From that number, I am removing 18 books, and that's a real number. Now, my hardcover books, I have 3 times x, and I'm actually adding 18 to that. The last piece of information that you need to input here is the new ratio. What does this equal? Our new ratio is going to be 4:1 paperback to hardcover. And typically I would write a P and an H just to make sure that I did not get this confused. All right, from here, it really is fairly straightforward algebra, and this isn't complex algebra, so this is algebra that I'm happy to do actually. I try to avoid doing algebra as much as possible simply because it tends to be time consuming and there is a tendency for mistakes as well. All right, so here I'm going to cross and multiply. 22x minus 18 equals 4 times 3x plus 18. Excellent. And then we just continue through here, right? 12x plus, I'm not going to multiply this out because I don't want to. On the official test, I don't want to, right? I don't want to be doing complex math that I don't have to do. I'm going to subtract 12x from both sides. So I'm going to get 10x, and then I'm going to add 18 to both sides. And I do think it's important that you actually do this math. All right, so 10x equals 5 times 18, right? And ultimately now I can divide this whole thing by 5. I have to do it on both sides of the equation. So I end with 2x equals 18, x equals 9. I do have a final solution here. Now, I just carried this all the way through. Really, at the moment that I set this up, though, this is probably the moment that I could have stopped if I was rushed on time. Because ultimately, I know that I can solve this. Just seeing the equation written out, I feel very confident that this is going to lead me to just one specific answer. And that proves that this statement is sufficient as well. So our final answer here is going to be D. All right, so I want to talk about what the hidden constraint is here, just to make that very clear. Here, our hidden constraint is the fact that our total number of books is going to be a multiple of 25. And we know that because when we think about this relationship of a ratio, we know that there are 22 parts paperback books to 3 parts hardcover. And so when we think about our total, we're going to add those together, 22 and 3. And you can come up with some specific examples for yourself that will demonstrate that relationship as well. So even on the official test, if you get confused about this, try to just use some examples, right? Don't bail on the problem immediately. See if you can come up with a way to make it resonate for you. All right. I'm going to show these takeaways on the next slide as well. The potential cost of missing this hidden constraint is an important thing to think about. You can solve this problem without noticing what I just showed you. However, what's going to end up happening is that you will use more time than you really need on this problem. So you'll be spending your time unwisely. You also might misunderstand statement 1 and assume that it is not sufficient. I've definitely seen students look at statement 1 and think, there are just too many options here. How could this be sufficient? And then assume that it's not. The third potential cost is just not seeing a clear approach and then skipping this problem when you could solve it. This is within your reach. All right. We're going to do another problem related to hidden constraints. I'm going to give you, that was about a moderate difficulty question. Yeah, thank you, Jessica. I'm going to give you another 2 minutes to attempt this next problem here. And again, I want you to spend some time understanding the problem. That is where you're going to notice these hidden constraints, right? You're not going to see them immediately. They're not readily obvious. You have to spend a little extra time thinking and planning. Okay. Take a deep breath. Let this problem go. On to the next one. You're going to have 2 minutes and your time starts now. All right, that was your 2 minutes. In chat, please weigh in. What is your answer choice? And do you feel like this problem is more or less difficult than the previous one? Okay, as you write that, I'm going to get started with explaining more difficult. Got a vote for more difficult. All right. Some of the difficulty level question, by the way, I get that a lot about how difficult is this problem. We can say that it's low, moderate, high difficulty, right? But ultimately, it's really telling as well for each of you to understand what types of problems tend to be more difficult for you. Maybe at even low difficulty levels, there are certain problems that you think, I'm just not ever going to get this type of problem right. And that's a really good thing to know, because as you think about your goal being to use your time wisely, your time is not well spent on those problems on the official exam, right? You're not going to get better. You're not seeking to enhance your skills when you're taking the official exam. You are trying to use your time wisely. So thinking about your weaknesses is very helpful in that context. All right, I'm looking at both of these statements, and ultimately I feel like they're about the same. So I'm going to just start with statement 1. All right, so I learn, and I'm taking time to understand again, if B and C are both positive integers. If you see this, this is like a gift to you from the GMAT test writers. Just give yourself a moment to thank them for this kindness to you. Because this means that you have to consider a lot fewer cases, right? And if you don't see positive integers, then you never assume that any variable is positive or an integer. All right, if B and C are both positive integers and B equals 2/9 C, what is the value of B plus C? So I'm looking for B plus C, which is interesting. Now, looking at statement 1, I see that 10 is less than B is less than 20. So my goal here is to prove this statement insufficient, right? I want to look at this and think, how do I attack this problem? How do I come up with a couple of different values for B plus C? So I know that B equals 2/9 C. Because of that, I can divide by 2/9 on both sides. And when you divide by a fraction, you actually multiply by the reciprocal. So I'm going to have 9/2 B equals C. Now this is a good thing to do for me right now, because ultimately I can identify what C is, so I can identify what B plus C is. All right, so I'm going to just try a couple of different possibilities here. 9/2 times B. So 10 isn't an option, but 11 is. But I'm saying that I'm going to multiply or divide rather by 2 here. So I kind of want to choose an even number, I think. So I'm going to choose 12. And I can simplify this to 1, 6. So C would be 54 in this case. And then B plus C is 12 plus 54. That equals 66. Now, to prove this statement insufficient, I need to find another possibility. I need to figure out something else that works here. Okay. Again, I want an even number, so I am going to choose 14 for B. Oh, and this is a 2. Okay, so I cross that out. This is now a 1. This is a 7. This is 63. 14 plus 63. I'm not even going to add it up. It's just so clearly different from 66, right? I know that this is not sufficient because I was able to get a couple of different options here. So I cross out A and D and I keep B, C, E in this instance. Now I'm going to take a look at statement 2. And it looks really, really similar. I'm going to write my equation again, right? B equals 2/9 C. And I'm going to pause for a moment and think about how this statement might be different than the first one because they look so similar. So I'm wondering if there might be any traps that are laid here for me. As I look at this and I think about my constraints, I realize that B and C are both positive integers. Here, what's going to need to happen is that C is going to need to be a multiple of 9 in order for B to remain an integer. And I'm seeing that because 9 is on the bottom here, just like 2 was on the bottom for B. So I wanted an even number. So if I look at this, the only multiple of 9 that I'm seeing in this range here is actually 27. This is going to be 1, this is 3, so B is going to be 6. And then C is going to be 27. B plus C is going to be 33. And that's really the only answer that I can get for statement 2. That is the only option here that's going to work out. All of the others will result in B actually being a non-integer, which is not allowed based on the information here. So my hidden constraint for this problem was a little bit different than the hidden constraint for the previous one, right? The clue that I saw that led me to believe there might be one here is that these statements were so similar to one another. Now, I told you that you should always choose which statement you start with very intentionally. And in this case, I really didn't, right? I said, I'm going to start with statement 1 because they look very similar. If you see 2 statements that look similar like this, try starting with statement 2. Because when you start with statement 1, oftentimes the GMAT test writers will hide something there, right? They'll make statement 1 not sufficient. Statement 2 will look similar, and you'll already have assumptions that you're making about statement 2. It's not safe to make any assumptions on the GMAT, and you can say that for both data sufficiency and the quant section, as well as in other areas of the exam, including verbal. Ultimately here, statement 2 is going to be sufficient, so our correct answer is B for this problem. And it all hinged on this idea of the hidden constraint that C has to be a multiple of 9, right? And again, is this critical to be successful in the problem? It's not absolutely critical, right? You can still solve that problem successfully without noticing this hidden constraint. However, you would spend more time likely testing cases. You also would be much more likely to test cases for statement 1, prove that it's not sufficient, and then simply assume that statement 2 is also not sufficient. So there's a much higher likelihood of error here if you do not notice that there is a hidden constraint coming into play. Some other important inferences that were occurring with this problem, first is that B must be an even number. So when we got to that idea that 9/2B equals C, then we saw that actually B has to be an even number. That wasn't, again, it wasn't absolutely critical, but it was time saving, right? I didn't test B equals 11. So I realized relatively quickly that I only had a certain number of cases that I should test for B. Ultimately, I only had to test 2 in order to prove statement 1 was not sufficient. And that's, again, your goal, proving not sufficient, right? Excellent. So I had a couple of thoughts about difficulty level. I would say that this one was slightly less difficult than the previous problem, but if you felt like it was more difficult to you, that is absolutely valid. It also means that, maybe fractions are a place that you have an opportunity to improve your skill set. So try to go out and find some problems that are like the problem that we just attempted, that are similar. And in the official guide, you should be able to find some to be able to continue your practice. Okay, excellent. We are going to do another problem here. The best way to learn about these hidden constraints, honestly, is just to kind of see some in practice. Just as a summary, the hidden constraints we've seen so far are that C must be a multiple of 9 for this particular problem. So we're looking at multiples, right? And then for the first problem, it was also a multiple constraint, that the total number of books must be a multiple of 25. But we saw it presented so differently, right? This particular problem, we saw it kind of hidden within a ratio. And then in the second problem we looked at, it's really hidden within an inequality. So you're going to see even the same type of hidden constraint showing up very differently for different problems. The best way to notice these and to be able to use them for your own nefarious or not so nefarious purposes is to make sure that you are spending that time slowing down and understanding a problem, and make sure that you note any important information like positive integers that you see. Okay, I promised you another problem, and another problem you shall get. You're gonna have 2 minutes to work on this one as well. Take a deep breath. And your time is going to start right now. All right, that is your 2 minutes. Please send me your answers via chat. And then also how difficult this problem was. Looking at this one, there are actually several different ways that you can go about solving this one. The first way really that you could do it is you could take a look at the algebra, right? So t minus 7, I'm using t for Tanya. So t minus 7 equals 2d. I always use variables that connect to what they represent in the problem. I'm not using x's and y's typically because those are very easy to forget. It's easy to forget what they're referring back to. And that's dangerous for algebra, right? If you forget what you're looking at, then you're gonna have to either be thinking a lot harder, spending more time, or you're gonna be making mistakes. Now, again, I could set up the algebra for this. Alternatively, I could think about what would happen after taking away the 7 apples. So this is an easier problem than the previous couple. And I'm seeing a lot of solution methods right away, partly because of that reason. As you get into more difficult problems, it's often less clear how you can go about solving them. So 43 minus 7 is going to equal 36. And I know that Tanya is going to have twice as many apples as her friend Dan. So if I think about Tanya and Dan, then I see that I have 3 parts. And then Tanya is going to have 24. This is after the 7 was taken away though, so I have to remember to add 7 to that number. The hidden constraint here though makes this problem easier. And again, it's not necessary to the problem. So you might be asking yourself, why memorize all these things and why think about hidden constraints? As I've mentioned, it can make a problem go a lot quicker for you. For easier problems like this, that's not particularly necessary, right? It's already a relatively quick problem. But this is my plug for how you practice is how you're going to perform. When you are looking at problems, practice problems, you want to solve them like you plan to solve them on the official exam. And you have to think that you're setting habits at lower difficulty levels that you will fall back on at higher difficulty levels. So even for the easy problems, you still need to be solving them in a way that sets you up for success on more difficult problems. So as I look at this again, I've got a couple of options. Algebra is always last on my list because again, time consuming, a lot of potential for errors to occur. Now, as I'm thinking about what types of numbers I'm looking at here, I'm seeing that we have 43 apples, and I'm going to subtract 7, and I get that 36 number, right? I'm also noticing that Tanya's going to have twice as many apples as her friend Dan. Now, if I think about multiplying a number times 2, an interesting pattern occurs, right? I can multiply any number times 2 as long as it's an integer, and I'm going to get an even number. So ultimately what I know is that I need Tanya to currently have an odd number of apples. And here's why. As I think about wanting her to have an even number, that's going to happen after we subtract the 7, right? Tanya gives away 7 apples, then she will have twice as many apples as her friend Dan. No matter how many apples Dan has, 2 times that number is going to be an even number. But I'm subtracting 7, right, which is an odd number. Which means I have to start with an odd number in order to get that even outcome. By virtue of knowing about that hidden constraint, I can immediately eliminate answer choices A, C, and E. On this problem, that isn't necessarily critical to success. However, even this problem, it could make it a lot faster, right? You don't have to do any work at all, no calculations. You just have to notice, oh, she'll have twice as many apples as Dan, and then think about what that means in terms of the type of number that you would expect. Ultimately, the correct answer here is going to be D, and you can reach that in several different ways. This is the clearest way that's written out so far, right? So 36, looking at this, Tanya has 2 parts to Dan's 1 part, and then I have to re-add that 7 because I took it off at the beginning. All right. Please feel free to send any questions you have by chat, by the way. So if you do have any questions about what we're discussing right now, I'd be happy to answer them. I'm also happy to answer questions about other areas of your quantitative prep. Okay, we are going to do one final problem for the evening. The recording actually will be available on YouTube. So yes, that will be available, should be available shortly. We are going to do, as I mentioned, one final problem for the evening. I want you to think about the hidden constraints for this one. I really do. So even if you notice other ways to solve this one, I really want you to think as you go through it, what are some of those hidden elements that make this problem easier that I could notice and maybe eliminate some answer choices or maybe make some connections and move my progress along a little bit quicker. Okay. I always counsel everyone, help my students to take a deep breath between practice problems and between problems on the official exam. I see people taking practice exams and official exams, and they'll miss several problems in a row typically. If you see yourself doing that, it might be emotional inertia, right? You might have gotten frustrated about one of the problems. It was difficult. You felt like you missed it, and that bleeds through to a couple of additional problems. Take that deep breath between. Just let it clear your mind. All right. You are going to have 2 minutes for this upcoming problem here. Deep breaths all around. And your time is going to start right now. All right, that is 2 minutes. Please send me your answers in chat. I love to see them, as well as how difficult you thought this problem was. All right, again, we're still on the topic of hidden constraints, right? So the first thing that I want to do is spend a little time and understand what's happening here. Our Cash, Brian, and Chelsea have suckers in 4 different flavors. If 1/3 of the suckers are raspberry flavored, how many suckers does Chelsea have? So this is really the piece of information that I'm looking for, is X. How many does Chelsea have? Not raspberry flavored, just total. And I know that 1/3 are raspberry flavored. And I like to write things out like this. When I'm given a relationship like this, I really want to make sure that I'm tracking exactly what that means, right? So here I have 1/3 equals raspberry over total. And whether I use that information eventually or it just helps me to understand the problem, it's going to be helpful. Okay, looking at this then, I'm scanning the answer choices, and I am seeing that we've got answer choices kind of across the board here, but a lot of odd numbers, which is interesting. Looking down the line here, then I'm seeing that I want to figure out how many suckers Chelsea has, and I know that 1/3 of the suckers are raspberry flavored. So I want to figure out raspberry over total, ideally, so that I can come up with how many Chelsea must have, right? Now, total is pretty easy here. I know that 22 plus 20 is 42. And then I have to add that X in there, which I don't know what that is. So this is going to be 42 plus X. The percent raspberry flavored then is going to help me come up with the number of raspberry flavored. So the way that I'm going to look at this is by estimating how many must be raspberry flavored in each, right? So for our cash, 50%, that's an easy number, right? 50% of 22, that's great. Brian's a little bit more difficult, 15% of 20. I'm going to do some benchmarking here and say that 10% equals 2. And 5% equals half of that. So 5% equals 1, right? So this is going to be 3. And then for Chelsea here, I don't know how many she has in numbers, but I do recognize that this is 1/3, right? So thinking about it as a fraction is a little bit more helpful in this case, potentially. So 1/3 x is going to be my raspberries for Chelsea. All right, and then I can add these numbers up just like I did for the total. And I'm going to have 14 plus 1/3 x. This is where you can notice the hidden constraint that can be very helpful. Did anyone notice it? What's the hidden constraint in terms of our answer choices? I'll give you just a moment to type. We've got something going on. Absolutely, I just saw it pop up here. We're looking at a multiple of 3. So I'm guessing, because the GMAT works in logic, right? I'm guessing that Arkesh, Brian, and Chelsea don't have bits of suckers that they've saved. They don't have an 1/8 of a sucker that they're trying to hold on to, right? They have to be whole numbers. So if I'm looking at 14 plus 1/3 x, I know that x has to be a multiple of 3. If I look at all of these answer choices, I can figure out quickly which ones are multiples of 3. A is going to be a multiple of 3, B is not, C is not, E is not. We're down to 2 answer choices at this point. Right now, if you have spent a lot of time on the problem getting to this stage, I would take a guess and move on, honestly, because you want to use your time wisely, right? And you've already got a 50-50 shot. Ultimately, though, because I wrote this out, this is going to be a lot easier for me to set up. So I know that 1/3 equals raspberry, so 14 plus 1/3 x over total, 42 plus x. And then just like we did earlier with another problem, we're going to cross multiply here. 3 times 14 plus 1/3 x equals 3 times 14. I typically don't multiply big numbers until I absolutely have to, right? And ultimately here, I made a math error. We're going to get 21 as the final answer. So looking at this, what we want to recognize is that the hidden constraint here is based on the fact that this must be an integer, right? The number of suckers that Chelsea has to yield an integer result. So when we look at that, I can get the answer choices down to just a couple of options remaining before finally choosing D as the correct answer here. All right, so let's take a look at the takeaways from this one. We've had quite a few different takeaways in terms of hidden constraints, but ultimately what I'd like for you to remember from this is that hidden constraints can relate to a number needing to be an integer. They also can relate to a number that needs to be a multiple of some other number. It can relate to evens and odds. There are all sorts of ways that this topic appears on the GMAT, and it's tested fairly frequently. So it's extremely helpful to recognize, spend a little time recognizing the hidden constraints that exist in problems that you are attempting. The potential cost of missing hidden constraints, you still can solve problems. I've mentioned that several times. So ultimately, you still can be successful. However, what you will see is that you're going to spend more time testing cases, or you're going to spend more time working backwards. You're going to ultimately maybe make mistakes when doing algebra. It's going to be a lot more successful if you find ways to minimize the work that you have to do. All right. That is all I have for you this evening. Please take this forward and make sure that you are thinking about hidden constraints within your answer choices in the future. If you have any questions related to your prep, I'd be happy to take a look at those now for just a couple of moments here. It's a really good idea also to think about methods of working differently, right? Solving problems differently. So as you think about solving using alternative methods, working backwards and using smart numbers are very helpful. And I used a couple of examples of those this evening. As you get closer and closer to your test date, those particularly matter to help you to move, to make progress in the couple of weeks leading up to your final test date, right? So somebody asked earlier, how can I spend my time wisely in the next couple of weeks before I take my test? Yep, exactly. Thank you. Sorry, Jessica and Josie, I just saw that. Yeah, Jessica, you're going to go back to that 14 plus x over 3, and you're going to see that ultimately it has to be 21. Yeah, so as you get closer and closer to your test date, you don't want to be covering content as heavily. You want to be thinking about strategies that will make you quicker, strategies that will help you to notice patterns more readily, and be prepared to be able to do that, because your final goal isn't just to get problems right. Your final goal is to use your time wisely on the official exam. And you really want to make sure that you practice like you plan to take the official exam. All right. Happy studying to all of you. I hope that you all have a wonderful evening and some wonderful studying ahead of you. I'm sure that you do. The GMAT is a fun test to study for. All right. I hope that we see you all again soon.